polynomial graphs? Pretty easy. So here's what's going to happen. Let's graph what these look like. Y equals x. Y'all remember that's just the linear parent function. Y equals x squared. That's like a, not like, that is a parabola. And then y equals x to the third. The cubic looks like this. So the good news is all of your even polynomial functions are going to behave like this. So I'm going to write y equals x to any even power. It's going to look like that, as long as the power is even. This is going to look like any odd power except 1. 1 belongs to that. All right, there's some more stuff that they have in common. What's the domain for all of these guys? What is that? All reals. Good. So listen. Since it is all real numbers for domain, it's always going to be all real numbers for all polynomials. I am not focused on the domain because it is what it is. I know it's that. What I'm going to be focused on is the end behavior of the graphs. Look at the end behavior here. Just the arrows. Let's just look at the arrows. Over here, I have an arrow pointing down. Over on the right side of the graph, I have an arrow pointing up. Y'all, when I talk about the arrows of EB, that's all I need. Because I know the domain. The domain's negative to positive infinity. What's the end behavior of this? What direction are both of these arrows pointing, up or down? That's right. We're just going to write 2 ups. The end behavior for this cubic is down, up. So that's going to be the end behavior, how we're discussing it. One more thing. Look, every graph, every polynomial graph is always up on the right, as long as the leading coefficient is positive. So let's take a look at this little middle part right here. Here's what we're trying to get across. So every even is going to look like this. Has an end behavior of up, up, yes, 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 unless you have a leading coefficient that's negative. If you have a leading coefficient that's negative, you guys know a parabola opens down when there's a negative in front. So what is the EB going to be? Down, down. Negative leading coefficient, always down on the right. Positive leading coefficient, always up on the right. Same with a cubic. So any odd power, guys, is going to look like this. Down on the left, up on the right, unless it has a leading negative. If it has a leading negative, then it's down on the right. Still opposite behavior for odds, but down on the right. That's your basic setup. That is all we're concerned about today. We're going to do some practice just with this concept. So if you notice, we have ourselves some graphs down here. All we're going to do with these graphs, guys, is we are just going to sketch based on the end behavior and the approximate location of HK. So if you notice right here, I have a positive leading coefficient. So I know it's always up on the right. It is an odd power, which means the end behavior is opposite. So if that's up on the right, this has to be down on the left. Let's think about where this transformation is. This is 2 places to the right. So let's say HK is like right on the x-axis right there. Now all I have to do is draw a cubic with this end behavior that goes to this point. So the first one is going to have a sketch that looks like that. Any questions on that? We're just focused on end behavior and the approximate HK. Let's look at this. Oh, look. a leading negative. If it's a leading negative, it is down on the right side. Look, the exponent's even. Even exponents have the same end behavior. They're both going to be down on the right and left. So where is HK? There's no parentheses, so it's just one movement below the origin. So we're going to draw an even graph that's down on both sides. Let's look at letter C. Ooh, you are not falling for this trickery. You are not falling for this teacher gotcha. You know to rewrite this in the correct order. Let's go ahead and write negative x to the third first. Then we have a 4. Remember that 4 is positive, so let's write plus 4. There we go. Now we can easily see the shape of this graph. Negative leading coefficient down on the right. Odd exponent, opposite end behavior has to be up on the left. Where is HK? Just 4 places above the origin, no parentheses. So go 4 places above the origin and draw a cubic shaped graph, but you have to have a down arrow on the right side. So it's going to look something like this. Any questions? Let's look at this last row. Ooh, there's 2 transformations happening to this. But I'm getting kind of ahead of myself. Let's just talk about the leading term here. There's no negatives, so I know it's going to be up on the right-hand side. That 6 is an even exponent, so it's going to have the same end behavior of up, up. Where's HK? Let's see, 7 places to the left, 3 places up. HK needs to be in quadrant 2. And remember, it goes up on both sides of the graph. So it needs to look something like that. Let's look at letter E. Do you know what kind of end behavior letter E is going to have? Is it going to be the same or is it going to be opposite? It is opposite because the exponent's odd. Very good. What does that negative tell us about the right-hand side? Good. It's down on the right, up on the left. Great job. Where's HK? Just 1 place below the origin, no parentheses, so no sideways movement. Now remember, it has to be down on the right-hand side because it has a leading negative coefficient. All right, let's look at this very last one here on this page. Leading positive is up on the right. Even exponent, same end behavior. Where's HK? It's going to be in the 4th quadrant. Over to the left one, down 2. So it's going to look something like this. 1, 2, 3. It is the 3rd quadrant. Yes, yes, yes. Quadrant 3. You're right. Good job.